Hello, this is Dr. Cole Woolley, and this lesson is called Understanding GC Principles. Now, this is the GCMS instrument that we're talking about to help us separate the components of Oman frankincense and Somalia frankincense. Now, let's just look at the GC portion. Now, GC stands for gas chromatograph. Gas runs through the GC column and helps separate the molecules. Chromatograph means a device that helps separate. Now, one drop is all that's required. One drop of essential oil is all that's needed. Even a fraction of a drop is all that's needed. The essential oil sample is injected into the GC, and all the components, 100 to 300 components, are separated by the GC. Well, let's look at an example of the separation. Look at all these molecules. Each one of these vertical lines represents a different molecule. For instance, there's two of them that are labeled. Linalool, it's a very large peak. In fact, you can't even see the top. And linalyl acetate, another very major component of lavender. In this case, we have two of them with names. What about all the rest? Well, that's the detector portion of the GCMS, the MS portion. The MS is what gives components their names. So in this case, we've labeled two of the components. But look at how the GC works. This is a scale of time on the bottom and intensity on top. So each one of these is a different component, and the height of the peak represents the percent composition. Look at what happens when we give names to all these components. These are only the major components found in lavender essential oil. Now let's look at some of the structures of the essential oil molecules. Now look at these. Do they look exactly the same? No, they're different. And the GC uses the difference in the chemical structure to be able to separate these molecules. Each one of these molecules has a name, a scientific name. Sometimes they have two or three names. In this case, we're showing you the most common names. In addition, did you know that each one of these components has an aroma, and not just one, but sometimes 3 to 5 aroma descriptors for each molecule? For example, if we go back to linalool, it has the aroma of floral, citrus, and sweet. If we look at linalyl acetate, we see it's called sweet, citrus, and lavender. Now imagine you taking all of these aroma descriptors and putting them together into one. That's what you call lavender aroma. Isn't that amazing? The lavender essential oil that you inhale and you say, oh yeah, that's lavender. It's actually made up of hundreds of different aroma descriptions all put together in one, and that's lavender. Well, let's look at the GC process. A sample is injected into the GC column. The GC column is in a GC oven. The oven is heated up, and as it slowly heats, the lighter molecules come off first. These are the small molecules, and they slowly separate from each other. Then, as the GC oven increases in temperature, the medium-sized molecules start coming out, separated from each other. And then lastly, as the oven heats up to its highest temperature, the larger molecules come out, also separating from each other. Now, this seems to be very difficult, but let me show you in a simple diagram. Here, one drop of essential oil is added into the injector. As we look at the sample, in this case, we're talking about 4 different molecules found in peppermint. They're just all mixed up. But as the oven heats up, they start to separate. The small molecules move first, then the medium-sized, then the larger ones. Let's look at them. The yellow ones here represent the lightest molecules. Then if we go back in the column, we see the green ones. They're also fairly light and they're separated from the yellow. If we go all the way to the red, these are medium-sized molecules. And then finally, the large molecule is in blue and it's just barely coming out of the injector. What's ready to leave is the yellow molecules. It's ready to leave the column and be detected. The detector at the end of the GC column determines the percent composition of each essential oil component. What is the percent of the yellow one? What is the percent of the green one? What is the percent of the red one? Now I made them in chains so you could see that the red one is more dominant and has higher composition than the yellow one. So let's look at the next slide. Once they come out of the GC and are detected, then they're placed on a chart. The chart is time versus intensity. In this case, the light molecule, eucalyptol, came out first. Then another light molecule, menthone, comes out next. That's the green one. Then you see the red dominant menthol. That's the minty aroma of peppermint. And then finally you see the larger molecule, methyl acetated. They were separated by the GC column and detected by the detector. In this case, we're going to talk about the MS as the detector for the GCMS instrument. Now, this is how the GC operates. It's very powerful. It can separate hundreds of molecules from a single drop of essential oil. Now, is that powerful? That's very powerful. So, in this lesson, we've talked about how the GC works, the gas chromatograph. It's a very powerful instrument in separating essential oil molecules. So if somebody asks you, what does a GC do? You can say that the GC can separate molecules found in essential oils.